The two types of errors that we discussed in the previous example with the water are called type 1 errors and type 2 errors. Type 1 error is rejecting the null hypothesis when it's really true. So this is where it would go here, type 1 error. Now, a type 1 error occurs when, for example, we're going to look at this distribution here. Suppose the null hypothesis is true. So let's say here mu equals 70 from our previous problem. And I get this sample right here that says x bar equals 70.5, and it falls in this region over here, and it's so far from the true mu that I reject the null hypothesis, but the null hypothesis is really true. So as we said before, this could happen whatever I set alpha to be. So if alpha is 5%, then this type of error would happen 5% of the time. 5% of the time I would get a sample that has a probability of falling in this 5% region. And so that would be our probability of a type 1 error. A type 2 error is failing to reject the null hypothesis when it's really false. So I wrote it as failing to reject to remind you that it's a type 2 error because you're going to have to know which one is which. So failing to reject the null hypothesis when it's false. So this is a type 2 error over here. So let's say that the null hypothesis value for the water safety is really not 70. Let's say the null hypothesis value really is like maybe 71 or something. All right. And so getting a 70.5 is possible even from this distribution. But what if I got something lower? What if I got something that was closer to 70? Like what if I even got 70? Okay? So if I get x bar equal to 70, well, if I get x bar equal to 70, that possibly could have come from this distribution. It would have been unusual, but it could have come from this distribution. But really, but when I'm looking at this as being my null hypothesis, I'm certainly not going to reject my null hypothesis when my sample mean is exactly the same or maybe slightly different. Maybe I got 70.1 or something. And it's still close enough to 70 that I'm not going to reject the null hypothesis. But I really should have, because really 70 isn't correct, 71 is correct. So this is called a type 2 error. Now, if I fail to reject the null hypothesis when it's really true, or when I reject the null hypothesis when it's really false, those are good things. So I'm happy with those decisions. Those are good decisions. But we always have the potential of making what's called a type 1 or a type 2 error. So let's look at a few examples of this. Now, we're not going to do any specific numerical examples here, but let's say we have a criminal trial in the United States, and we say, is the defendant guilty of the crime? Well, our null hypothesis is always that the defendant is innocent until proven guilty. So that's our null hypothesis. And the prosecutor is trying to find evidence that the defendant really committed the crime. So they're trying to find evidence for the alternate hypothesis that the defendant is guilty. So what would a type 1 error be in this case? Remember, a type 1 error is when we reject the null hypothesis when it's really true. So we reject the innocence. We say the person is guilty. We declare the person who's guilty who's actually innocent. And the innocent person gets punished. What would a type 2 error be? Well, a type 2 error happens when we fail to reject a null hypothesis that is false. So here we say that the person is not guilty when they really are guilty. We don't find enough evidence to declare them guilty. Now notice we don't declare the person innocent because you can't prove innocence, but you can fail to prove guilt, and this is what's happening. We fail to prove they are guilty, and the criminal may go out and commit more crimes, and it could be dangerous. Now, if we ask which one's worse, a type 2 error or a type 1 error? Well, in the water bottle example, the type 2 error, where we failed to find evidence of bad water when there really was bad water, that would be much worse because people would be out drinking the bad water and not realizing it was bad. So the type 2 error was much worse. But in this case, it's kind of a toss-up. Which is worse, that an innocent person is punished or that a guilty person goes free? it would probably depend on what kind of crime the guilty person committed, what we thought. Maybe if they were a dangerous, murder, torture person, we would definitely not want them to go free. If they committed check fraud at a bank or something, that might not be as big of a deal. And we certainly wouldn't want to see an innocent person punished. In our judicial system in the United States, it's set up so that our judicial setup is set up so that a type 2 error is considered worse, and we are more likely to let an innocent person go, we are more likely to let a criminal go free than to punish an innocent person. In other countries, they may think the type 2 error is worse, and they're more likely to imprison someone improperly because they don't want to let a criminal go free. So it just depends on your point of view sometimes. So let's look at another one. What about when you're doing a clinical trial of a new drug to find out if it's effective in treating a disease? Well, we start out as our null hypothesis that it doesn't do anything, it's not effective, because we're trying to find evidence that it is effective. That's what we want to find evidence for, and whatever we're trying to find evidence for is our alternate hypothesis. So our alternate hypothesis is that the new drug is effective in treating the disease. So let's look at the type 1 and type 2 error here. So remember, type 1 error is rejecting the null hypothesis when it's really true. So to reject the null hypothesis, we would have to find evidence that the new drug is effective. So we find evidence that the new drug is effective, but it really isn't. So people buy a drug that doesn't work. Maybe the company gets sued. Maybe people choose the new medicine over the old medicine. They might even get sick or die because they're not using their old medicine and the new medicine doesn't work. So that seems pretty dangerous. Remember, the type 2 error is failing to reject the null hypothesis when it's really false. So we don't find evidence that the new drug is effective. We think the new drug doesn't do anything at all. We don't find evidence of its effect. So we don't find evidence that the drug is effective when it really isn't, when it really is. So in this case, the company loses money on a possible new drug that they could be selling. People lose out on a possible new cure. Both of those are pretty bad. I would say maybe type 1 is worse, probably. Although, once again, it would depend on what this drug is curing. But I would say probably people buying a drug thinking that it's working when it really isn't is probably worse. Okay, so what next? Let's look at quality control. This is something where we use statistics a lot in business. We want to know if the parts that you're manufacturing, the manufactured product, is meeting required standards. We are trying to find, now we can't prove that it is, but we're trying to see if there's evidence that it isn't, okay? We want to find if there's evidence that it's not meeting the required standards. So we start out with the null hypothesis that the part meets the required standards and the alternate that it doesn't. And quality control people probably hope that we don't find evidence that it's not meeting the standards, but that's what we're specifically looking for. So remember, the type 1 error is rejecting the null hypothesis when it's really true. So we say the parts don't meet the standards. We reject the null hypothesis and say the parts don't meet the standards, but they really do. So that causes the company to shut down production, to fix machines that don't need to be fixed. They lose a lot of time and money in their production process. In a type 2 error, we don't find evidence that the parts are defective, but they really are. So the company sells defective parts. Maybe they get sued. Maybe people are injured because of a part not working properly. So probably a type 2 error is worse. The company doesn't like to shut down production and lose time and money, but it might be worse to lose their reputation by selling bad parts. So when we're dealing with type 1 and 2 errors, it depends on the situation which one's worse. And so depending on which one you think is worse in a given situation, you're going to set your alpha level at different values. Because remember, alpha is the probability of a type 1 error. So if we don't want to commit a type 1 error, we could reduce the alpha level. If we are more concerned about the type 2 error, then maybe we make the alpha level bigger. So we'll talk more about how alpha and type 1 and type 2 errors and something called power are all interrelated in a later section of the chapter. For right now, be able to identify what the type 1 error and the type 2 error in a situation are and their consequences or possible consequences.